Okay, it says here, the graph below is an example of a step function. Where have we seen this before? The step function.
Oh, on that Desmos thing.
On Desmos, when we looked at the eggs. Do you remember the video of the eggs in and out? Well, now we're going to be working with them. Step function.
Working with eggs?
No, step functions. As you examine the graph, determine why you think it might be called a step function.
Because it looks like stairs.
Thank you. Okay. Looks like steps.
What?
Did she say she was confused? Okay. I hadn't even started yet. Okay. 2. Why do you think this is also called a discontinuous function?
Because not everyone is represented.
So if it is continuous, that means once you put your pencil down to draw it, you never have to pick your pencil up. Continuous function. Here, can you draw this without picking your pencil up?
No.
So it's discontinuous. 3. Is this graph a function?
Yes. No. Yes, it is. For one reason. Those are open circles, meaning it starts right after that first one. So, like, smart.
So if I draw these vertical lines, how many times do they touch the graph?
We learned this
Once.
I didn't learn much about 8th grade.
Twice. That's still once. Because it's an open circle, meaning it starts right after that point.
And what did we learn yesterday about domain?
It's an open circle.
Open circles were not included. Remember, we went all the way up to the open circle, but we didn't include it. So even though this line touches the graph twice, this point isn't really on the graph.
Then why is it there?
Because it's an open circle, letting me know this line goes all the way up to that point, but it doesn't include that point. Remember, we said it's just less than, not less than or equal to, like we talked about yesterday.
It does it so that you don't have to get right there at it.
Because you can't.
Because you can't.
You can't get all the way next to 2. Because whatever point you stopped at, I can name another point that's closer to 2 than wherever you stopped. No matter where you stop.
So if I stopped at 2, could you know a closer point than 2?
No, because we're not including 2. Pick something closer.
Point to 2.
Closest point to 2 that's not 2.
1 point. 1.9. I mean 1.9. Repeated.
Okay, well that's a whole different ball game. Because
Mainly.
1.9 repeating is 2. That's the same number. That's the other thing I'm going to show y'all. So you can't do 9 repeating forever because that is 2. They're the same number.
Now why would you not just say that?
It says the graph describes how much it will cost to send a letter depending on the weight of the letter. I've labeled the steps so you can better understand the explanation below. Step 1. If the weight of the letter is over 0 ounces, right? That's what step 1 means. We're over 0 and up to 1 ounce since the circle is closed. So from 0 to 1 ounce, it's going to cost me 39 cents to ship it. Now if it's more than an ounce, all the way up to 2 ounces. More than 1 ounce, all the way up to 2 ounces. It will cost me 41 cents to ship. Do you follow where this is coming from? The third step. If it's more than 2 ounces, up to and equaling 3 ounces, it's going to cost me 43 cents. And so on. As you can see, the graph tells you exactly how much your letter will cost depending on the weight. A discontinuous graph must be used because the price stays the same between ounces, but then changes to the next price as you reach a whole ounce. Okay, let's look at 5. It says, hold on, $15 per shirt for a shirt between 21 and 40, $10 a shirt for shirts 41 to 80, and $5 per shirt if the shirt order is over 80. So what would that look like as a graph? Okay, So if I ordered anything up to 20 shirts, what am I paying? $20. So again, this is the number of shirts is the X. The price per shirt is the Y. So if I ordered no shirts, all right, we could put an open circle there because you're not going to order no shirts and get charged $20 a shirt, right? So that point doesn't make sense. But whatever I order, from here to 20, and 20 is included. Right, you see that? Because if I order 20 shirts, I'm still paying $20 a shirt. But as soon as I jump to 21, I'm dropping down to 15. I don't like this graph. I'll be honest with you. I don't like it. Does anybody have any problems with this graph, or is it just me? What problems do you have with it?
That and give you the other lines, so it's not.
Well, that's part of it, but I don't like the premise of the problem.
It's going backwards.
It is going downstairs from 40 to 80. Okay, maybe I'm the one that has the problem with the shirt, with the graph. And then 5 for over 80. The reason I don't like it is because I don't think these lines should be connected, because you can't order half a t-shirt, or I mean that's what we've just been talking about. So I don't think it should be and maybe it's not supposed to be. I'm not looking at the teacher's one. So
You weren't supposed to make it is this gesture with a discontinuous function, but I guess that
this still is discontinuous.
with the just the dots be okay.
Because if I had to pick up my pencil to draw it, it's still discontinuous.
Yeah, I don't know.
I'm gonna go look at the answers in just a second.
They probably did it this way because it's in the 10, so you don't want to put 10 dots.
Yeah, I mean it would be. Anyways, that would be the graph. Back to the graph. How many shirts did I order?
40.
I ordered 40 shirts.
That's wrong.
It's not wrong. I ordered 40 shirts. How much money did I pay per shirt for 40 shirts? It's up here at $15. So I would do 15 times 40, which gives you 600, and then $10 shipping would be 610, right? Okay, everybody sees number 6 here. It says you've ordered 40 shirts and must pay shipping fees of $10. How much is your total order? So let's. Shipping's $10 total, not $10 per shirt. If it was $10 per shirt, that's quite the shipping fee. Okay. Now, here's my question.